In our data analysis unit, we have 3 standards. 2 are supporting 1.8a and C, and 1 is the readiness standard, and that's 1.8b. Now, kindergarten has 3 standards that support this unit. So we have K8A, which is where students are expected to collect, sort, and organize data into 2 or 3 categories. K8B says students use data to create real object and picture graphs, and K8C, where students draw conclusions from real objects and picture graphs. So let's talk about what first graders do. We know now what a kindergarten student has to do, but what do we build on from that? So in 1.8a, this is where students have 3 verbs. Collect, so the student is collecting, the student is sorting, almost skipped one, and the student is organizing the data. All of those verbs belong to the student. These are student verbs, not teacher verbs. The students own those verbs. Now, they collect, sort, and organize data in up to 3 categories. Not 4 categories, which is what you'll find a lot of resources. So you have to really watch carefully that you've got 3 categories. Now, what do they do with that? They use models or representations such as a tally chart, a tally mark, or a T-chart. So in this standard, this is how we are going to collect, sort, and organize our data, with a tally mark or a T-chart. So we start by learning how to do this with 2 categories before we expect students to move to 3 categories. And we remember up to 3 categories means no more than 3. So I can't do 4, only 2 or 3. And then we make sure that when we are creating this T-chart that we are labeling everything. The title, we're going to say what the categories are for our T-chart, and then the students display data with models, manipulatives, and paper. Remember, in kindergarten they did real object and picture graphs. So if we want to connect to what their prior learning is, then we're going to start by making real object graphs, and we can do that with things like linking cubes, teddy bear counters, 2-color counters, square tiles, centimeter tiles, all sorts of manipulatives that we can use. So you could have students write a survey question, because remember, they're going to collect the data. They could write a question and give 3 choices, so they could set up 3 small cups on their desk with the 3 choices to represent the 3 categories, and everyone rotates by each desk to answer each question by dropping a color tile in 1 cup per desk. So that's a fun way to teach kids how to collect data and then sort and organize that into a T-chart using tally marks. The next thing that they're going to do is 1.8b, which is our readiness standard, and that's where students are going to use that data that they collected to create. Use data to create. So who's doing the creating? The students own that verb. Picture and bar graphs. So they have to make picture graphs and bar graphs. So there's some important things to talk about here. Start with picture graphs. That's what their schema built on from kindergarten. Begin with those picture graphs. Remember that a picture graph always has to have a title, but if the pictures that are being used indicate what the response is, then a label isn't needed. For example, here, I need to know what these categories are because these are just smiley faces. The smiley faces don't tell me what category, they just tell me how many students we're talking about. But in this one, if I didn't have this at the bottom, would I still know what the favorite school lunch survey was about? I would know it's about picking, is pizza, hot dog, or sandwich my favorite. I can have a title for each of these, or a label for each of these, but I don't have to if the picture that I'm using tells me what the response was. So in first grade, This would be a complete graph without those labels because the picture tells me what the response was. Now, something else that's important for first grade picture graphs, the scale is always 1. So in first grade, this smiley face can only represent one student response. It can't be smiley face equals 2 and we count by 2s, or smiley face equals 5 and we count by 5s. In first grade, the scale is always 1. I also want you to notice that I've given you 2 different examples here of picture graphs. One's horizontal picture graph and one is a vertical picture graph. We need to have variety so that our kids see both kinds. That's the same for bar graphs. We want to make sure horizontal and vertical variety is shown. Now let's look at a bar graph for a first grade student. Every bar graph is going to require a title. It's going to require labels for the x-axis and the y-axis. Students don't need to know x and y-axis. It's going to require an increment of 1 in first grade. Notice we're not counting by 2s, 5s, 3s, 10s, hundreds. We're counting by 1s. Only an increment of 1 in first grade. Now, I also want you to notice that in first grade, these bars can be partitioned so students can see how many sections there are to know what the vote was. That helps tie it to what they know about reading a picture graph. So that is acceptable in first grade. All right, notice 3 categories. I can't have 4 categories. I can only have 3, no more than 3 categories. Okay, and then last we have 1.8c, and this is that thinking standard like we talked about in other units. In this, the students have 3 verbs. They have to draw conclusions, they have to generate questions and answer those questions. From both picture graphs and bar graphs. So let's talk about what that means. There's a difference in asking questions that just require students to identify information from the graph and a question that requires them to draw conclusions from the graph. So let's talk about what that might sound like if we used this graph. In this graph, I could ask students how many people voted in this survey, and they could count them all up. I could ask students how many more students voted for hot dog as their favorite lunch than submarine sandwich. I could ask how many students picked pizza and hot dog. I could ask lots of questions that directly come from counting the information on the graph. That's a factual question. But I could also ask questions that require them to draw conclusions. That's what 1.8c's standard is. That sounds like, what menu item should the cafeteria order less of? Why? So now I have to draw a conclusion. I should order less submarine sandwiches because not very many people wanted to eat that. What should the cafeteria order more of? They should order more pizza because it was the most popular lunch item. If I looked at this, I could ask questions like, what category do the most students like? Well, the most students liked sports. How did you know? It had the most votes. So I have to ask questions beyond how many of this, how many of that, how many combined, how many different, how many more, how many less. Now, I also have to watch for misconceptions that the size of the symbol tells how much, and I don't know that I have a good example here. If I have this in a vertical bar graph, some students tend to think the larger the object means that there's more, because if I lined these up, it would be long. So we have to make sure that they understand it's the number of that object, not the size of the object, that determines how many votes a particular item got in the survey. So the big thing here is that in all of these, the student has the responsibility for collecting the data, creating the graphs, using the data, generating the questions, answering the questions, drawing conclusions. The students have the responsibility for all of that in this standard. So we should not have a lot of opportunities where they're just given a graph and asked questions. That doesn't really fit what our standards expect our students to do, where we're just giving them a graph and saying how many of this, how many more of this. We need to see those questions, but that shouldn't be the majority of our learning, because that's not what our standards require of our students.